right, so here we go. 4.5, yeah, this is outcome A3. This is negative exponents, and I already said it was outcome A3. So what we're going to do first is we're going to look at where a negative exponent comes from. And let's show this by an example. So suppose we had 7 to the power of 5 divided by 7 to the power of 9. Okay? Now, if I were to write this in expanded form, I would have 7 times 7 times 7 times 7 times 7. So that's 5 sevens, right? And then divided by, how many 7s am I going to have down here? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Now, you agree that this is 7 to the power of 5 and this is 7 to the power of 9? Yeah. Okay. So if I have a 7 over 7, I can reduce that. What does each 7 over 7 reduce to? 1. Okay, so each of these crossouts, a 7 for a 7, reduced down to 1. So what am I left with in the numerator? 1, because it's all times by 1, right? And then how many 7s do I have left in the denominator? So I can write that as 1 over 7 to the power of 4. Okay, now let's look at those exponent laws that we experienced from grade 9. So our quotient of powers says that if we are dividing, if we have 7 to the power of 5 over 7 to the power of 9, 7 to the power of 9, what's the shortcut? What do I do with the exponents? I subtract them, so I can go 7 to the power of 5 minus 9. What is 5 minus 9? It's negative 4. So I've got 7 to the power of negative 4. Now, do you agree with me that this question I wrote as this, right? Yeah. And notice right here, that's the exact same thing I wrote? Yes. Those are exactly the same here. But here, what I did is I solved it by expanding and then reducing, and I ended up with 1 over 7 to the power of 4. Over here, what did I use? I used our power of, our quotient of power law. So we subtracted the exponents, and what did I end up with? I ended up with 7 to the power of negative 4. Now, do you agree that I've done everything correctly so far? Yeah. Is everything believable? Yeah? Okay. So if I started at the same place, I did the operations I did a different technique for this, and I did a different technique for this, right? Yeah. And I ended up with this and this. So what can we conclude about those two statements? So 1 over 7 to the power of 4, it should be equal to, and in fact it is, equal to 7 to the power of negative 4. All right, so we see whenever there's a negative exponent, what it does, if you wanted to write it with a positive exponent, you would have to write that base in the reciprocal position. So if it was originally in the numerator, which in this case it was, we could write it with a positive exponent in the denominator, and vice versa. So let's get into some of these examples here. What's the first example? Says, okay. All right, I'm still alive. So let's have a look at 1a. It says 7 to the power of negative 2. So what effect does that negative exponent have? So from 7 to the power of negative 2, I can rewrite that as 1 over 7 squared. So I've got 1 over 49 as the answer to A. All right, so now here I've got 10 to the power of negative 3. Sorry, and 10 over 3 to the power of negative 3. So in order to make that exponent positive, what do I need to do to the base here? I need to find the reciprocal of it. 10 over 3 to the power of negative 3 is equal to 3 over to the power of positive 3. Okay? So now what is my next step to evaluate? 3 to the power of 3 over 10 to the power of 3, which is? 27 over 1,000. Good. Okay, and now part C. The best way to do this question is to convert it to a fraction first. So what is negative a half as a fraction? Negative 3 over 2 to the power of negative 3. Now, what effect does this negative exponent have on the base? Yeah, it turns it into the reciprocal. So anything that has a negative exponent, flip it, right? So 2 over 3, it's still negative, to the power of positive 3. And now I'm going to have negative 2 to the power of 3 and 3 to the power of 3. So that is negative 8 over 27. So that's my answer there. Sound good? Okay. Now, number 2, these are written really small. So, excuse me, just in case you can't see, that's what it is. How can I get rid of this negative? How can I make this exponent a positive exponent? So you'd have 1 over 16 to the power of 5 over 4. Now, we've got an exponent that's a fraction. Do you recall from last lesson where we did fractional exponents, what effect this has? If you ever have a fraction in the exponent, the denominator tells you what root you have to do. So then, which root is this? This is going to be the fourth root of 1 over 16, and then you have to take the 5th power of that. So evaluate this. What is it? 1 over 2, and that's to the power of 5. So what do we get then? 1 over 32. So the 5 goes to this, and the 5 goes to that as powers, right? Okay. I can just write that here, just so 1 to the power of 5, and then 2 to the power of 5. And that's how I get this. All right, so now this question, I'll write it out just because sometimes the printing looks a little difficult to read. It's a little small. 25 over 36, all to the power of negative a half. Well, how can I get rid of that negative in the exponent? Well, how do I change my base? I flip it. I have the reciprocal of it, and that's going to be to the positive 1/2 power. What does 1/2 as a power, what's that operation? Square root. So that's going to be the square root of 36 over 25. So what is that? What's the square root of 36? And what's the square root of 5? Sorry, 25. So 6 is the square root of 36, and 5 is the square root of 25. Okay. Now, that's pretty much it for the lesson in terms of doing this by hand. Now, the key is just practicing all of this, right? So this last example here talks about using the formula, and this is, you're going to have to use a calculator for this one. So if you use a calculator for this one, you're going to substitute the S value and the F value here. And I didn't state the units, so let's say that it's meters per second. So we would just have V equals 0.0155 S, which is, S is 1.5. 1.5 to the power of 5 over 3 times F, which is 0.3 to the power of negative 7 over 6. All right, so using your calculator for this one, and just make sure that you're typing things in okay. If you've got a fraction in the exponent, then you might have to put a set of brackets around it. So let's see if you can see what I have to type in. 0.155 times 1.5 to the power of, and I'm going to put a bracket around it, 5 over 3, 2 brackets to close that in, times 0.3 to the power of, and I'm going to put a bracket around that, negative 7 over 6, close bracket, so that my exponent stays in the bracket. And I end up getting 1 point, oh, am I missing a 0? No? I think I'm okay. I'm good. 1.2412 meters per second. So that's how fast our little dinosaur is. All right, so that's the end of that. So again, to summarize, what effect does the negative have in the exponent? Makes it flips it, right? So if it's in the numerator, then it goes to the denominator and vice versa. And what do we do when we have a fraction in the exponent, like these questions up here? What is the denominator related to? The root, okay? All right, so your homework's on page 233. I've also got a worksheet for you guys that you have already, I think. So let's get on that.